To write a test method in BlueHill 3 software, the thing we mostly needed is a little bit of experience and idea how the software works. So it's better for if you are trying to write a method first time, it would be better if you have someone who has written the test method before and help you out with the writing the methods. In few minutes we will see how to write a test method in BlueHill 3, and then we'll see some examples. To start writing a method, first we have to click on the method button here, and then we can see here these are the lists that other methods have written previously. So you can go clicking on them and then look at them before you write your own, but here we will start with a new one. So it's here there's the option that you can use the existing methods or you can create a new one. So upon clicking on the create method, it will ask method templates, like what kind of method we want to use. It has a lot of options like tension methods, compression methods, creep methods, metal methods. So depending upon what you want to do, you have to select one of the options. So let's say we'll do a simple tension test. So I will select tension method, and then I have to press next. So now on the methods tab, we have a lot of options to follow. So it's simple that if we follow one by one till the end, it's kind of the methods is kind of ready. So at the first in methods, the test type is tension that we're about to do, and then system of units. So here's like SI units, metrics, US customary, whatever you want, or like we can keep it like all, so we can get the data in all systems. So assign specimen parameters, method defaults. So and in method description, you can write for this test we can write like, okay, tension test until the specimen breaks, like a little bit description, so that when we get back to the method again, we can track back really what are really we wanted to do to these methods, kind of a details. So next we will click on the samples. So it's a sample description, simple things like what kind of materials, like 304 stainless steel, and for which part, and what reason, whatever, and notes if there is 2 or 3 samples you want to run. So I will say, like, for now 304 stainless steel tension test, and then we'll go to specimen. Okay, no, number of inputs. Sample number of inputs is really doesn't need to change if we want to run a general test. Text input, if you have any sample text to write specifically about the samples, you can write here. Not a mandatory one. So next, the specimen. So here we have to give the information about the testing specimen. Now you can see it's a flat rectangular, because here is a rectangular option showing. So as we are using dog bone specimen here, so we'll choose circular, because the portion we are concentrating on the dog bone specimen is this circular cylindrical portion. So we'll select circular here, and the diameter we can use it millimeter, meter, centimeter, whatever. So for now it will give millimeter. So for geometry and default dimensions, we have to enter the dimensions of the specimen. So if it's in inch, for now we'll give it in inch, say 0.25 inch, and then length in inch, say 1 inch. So for final length and final diameter is not have to be a fixed value. It's so it's a tension test. We have to give an estimation of any value, like final length was the previous was 1 inch, so it's a tension test. So the final length would be more than 1 inch. So we put 100 millimeter, and then the diameter was 0.25 inch. Finally, the diameter for tension test should be less than that, but you can put any value you want. So it doesn't really matter that much. So notes, if we have any notes, number of inputs, really doesn't matter that much. Text inputs, if you have any, and then choice inputs, if you have a specific choice. For now, we will leave it like that. It doesn't really matter that much. So measurement, create and edit measurements. So in the measurement tab, it will ask for create and edit measurements. So what we want to measure from the software. So it's says selected measurements available in the test method is like time, extension, load. For tension test, we want these things: tensor extension, tensor stress. We can get that. If we want to add more, we can add strain here. If something pops up, just read through them and then just take actions according to that. So for now it's good. So next step, we'll go to calculations. So what we want to calculate: percentage of break, area reduction, area under curve, whatever. So we may want to calculate area reduction, and what else? Peak first, or in value, Poisson ratio, break locations, break. So upon your need, you can add things that will calculate it from the data. The software can calculate these terms for you. So rounding, if we need any rounding, we'll leave it like that. Test control, start test, how we want to start the test, like test button or any other lines. Like these are the digital analog lines if we want to run the test from another system, so it can get commands from its analog wire or like a remote wire. So for now we'll say that by the start button. So if we press the start button, the test will start. And then strain, how we want to measure the strain, tensor strain, extension form. So we'll select that, and pre-test, temperature soak, preloads if there is any, auto balance, recycling. So we don't, I mean, these things will make it more precise, but in normal cases we don't need that. And test, to run the test, like the ramps, control mode, how we want to control. So it says that if the extension option is chosen, so it means that the frame will exert load on the specimen on extension rate, like millimeter per minute. So if we know how much millimeter we want to extend per minute, so we have to include that value, say 0.001 millimeter, like 0.1 millimeter per minute. We can do that. Also, if we want to say, okay, I want load. So how much load I need per newton per minute, or day per minute, and kilonewton per hour, whatever. So I will say, like, for now, newton per minute, we can give say 700 newton per minute. Okay, newton is like too low. We can say kilonewtons per minute. So, and we can say like 70 kilonewton per minute, 700, whatever you want. It depends on the elastic limit of the specimen, and this is the way the frame will apply load on the specimen. So there's also a calculator if you want to do some calculation roundup options we have. So we'll leave it like that. And there's a RAM 2 option that after something we want to do like loading, then we want to do some unloading, or like load but in deceleration or something. So we can do that. And then the test and end of test, how the test will end. So end of test, rate of load. So we can select that if the rate of load is like in 40%, it will shut off. We can say that load threshold, like that if the load is say 700 kilonewton, so it will reach the threshold point and the test will end automatically. So we can also do that. Percent peak load, we can do load drop. If the load is dropped, the software will shut down, I mean close the test. So it asks first how we want to end the test. That's it. And then data, the end of test action, so like stop, it will stop the test, or return, like it will return to previous position, or like stop then return. So the test will stop first and then return back to original position. So in the process of writing, you may want to save your methods anytime you want, like press here save and close, or like save button. It will ask where to save. For now I'll save the test methods in desktop, like test 1, and then I'll say save. So the method is saved now. So if I shut down the software and turn it on again, it will show that this method is already written, so I can start from there and edit it. So for the test control data tab, we have to set how often we need the data, like what time interval we want to register the data. So data capture will put manual, and criteria 1, how often we want our data to be taken is a millisecond. So for now we say that, okay, after every 50 milliseconds we want to register a data, we can do it by day, hour, and minutes, whatever. So this is the test control section, and then console. So here in optional feature, what we want to see in the monitor when the test is being run. Live display. So what do you want to see? For now, we'll say like we can observe maximum 4. Now we'll select like extension, what units we want to see the extension, millimeters. So you see the display is showing extension in millimeters, and then load, how much load we want to see in the monitor during the test. It's in Newton, so number of digits, we can choose that. It will show during the test, and we can select others if we want, soft keys if any needed, but it's not necessary. We'll leave that. Frames. So test it is kind of a thing like set parameters for the frame test area, whether we're testing above the crosshead or like below. So below crosshead for sure. And specimen protection is kind of a safety for the specimen, that if we turn it on, if there's any way the load reaches this limit, the software will automatically shut down the test. So we do not do it when we run the test within elastic limit, but there's an option that we can protect the specimen if we want. Grips, we don't need that. Enable protection or enable access tension, we don't need that. So console tab is ready, and then we will go to workspace. So select the parameters to display on the test workspace. What do we want to get displayed? Thickness, length, weight, width. That's the thing general we need, and then sample number you need, inputs if there's any. Sample text input doesn't matters that much. So now for workspace tab, operator inputs, what parameters we want to display, and then setup, results, result 1, that columns, what the results I add selected results option. It will add a column on the Excel file that in that it shows the results. So if here 10 terms is added, like specimen level, maximum load, tensile stress, tensile strain. So in the result Excel file there will be these columns, and it will have the data. So these are the columns that will create, and then statistics, what we want to see, maximum, mean, medium, minimum. We can select or deselect any one of them if we want. So this is result 1, and then the format, how the table should look like after the test when it gives us the results. So we can change it, the style, there's a lot of style, colors, the way we want. So there is also a result 2 option, but for this test we don't need any result 2. But if it's like a 2 sample at a time, or like there's a 2 section of the test, 2 part of the test, so we may want like, okay, result 1 and then result 2, or like we want 2 different Excel file. In result 1 we may need loads and tension, and then in result 2 we may need another thing, so we can do that too. There's also an option for graphs. What do you want to see? It'll plot automatically into graph, like in X and Y. So for the graph option, there's like type, what type of graph I want, multi-specimen, control chart, double y-axis. It'll show load in, y-axis, both sides. So multi-specimen, number of curves per graph, 4, 5, like how many curves you want. Then X data, what we want to see in the X direction. Instead of extension, we can have load, we can have a time, unit, second or hour, whatever unit we want. And in y-axis, we can have load. So the graph will show that during time how much load it applies. And there's also an option for graph 2. We can also choose the type, and then X data, we can see extension, how much load needed for a specific extension. So we can choose this kind of graphs to get out from the software. Raw data, what raw data we want. Each measurement added to the selected list create a column in the raw data table. So whatever we add here, like time, we can exclude, or time is important, so we should include that. Extension, load, if we want to use tenacity, tensile extension, we can add them to, it will create a column in the raw data file. So format, what format do you want in Excel format, and then there will be like columns on each term, and then it will put the values here. Extra display, if we want to get displayed anything else. Layout, what layout we want our answers. So this is the layout, like a graph and a specimen. We can choose two graphs, whatever layout we want. This is the basics. Custom, you can, if you want to customize, you can do that. So this is about our workspace. So in the export tab, there's file setting, reports, file setting, edit the output file setting. It will save automatically a file. If we want to specify a default file name, we can do that. Reports, which format I want, PDF, MS Word, HTML, template, all items. Print the report if we want to print them. So export result. If we want to export the result in a CSV file, we can do that. Export raw data. We want to export the raw data to separate file for each specimen where you finish the sample. So we can do that if we want. Default table. It uses a default table to include parameters that remain constant for all specimens in the sample. So these are the things that is not necessary, but we can do that, like selected parameters like company name, laboratory name, operator ID, rate 1, humidity, temperature. We can say that these are fixed. They are constant throughout the test, and prompted test if we want to do that. If we want to run as a prompted test, we can do that too. So this is the basic about writer methods, but each test has a specific sensitivity, a specific states, like for creep, we may need a lot of cycles, so the writing of methods won't be the same for the. So this is the basic of writing a method in BlueHill 3 software. Every method has a specific situations, like depending on what kind of test we want to run. For like tension test, it should be like tension, and should we stop the test before break or after break. If it's a creep test, like constant load and long time test, or like cyclic test, loading and unloading, loading and unloading, for the fatigue test. So depending on the type of the test, the method should be different, and it comes after through experience. Writing one, start writing with the simple one, like the simple compression test, simple tension test, simple breakdown test, and then add those experience to write basic the real test, like complex test, creep test or fatigue test. So this is pretty much it. Now we'll see how method looks like as an example. So for an example, we can choose any method that is pre-written to understand it. Here's the test one that we have created this morning, 9/25/2014. But we'll see a little bit complex one, like cyclic strain rate test that we have written before. So how it looks like. Methods, tension, test profile, system of units, all, assign specimen parameter, method defaults, sample, how was the sample, it's not necessary to write all of them, number of inputs, just leave it like that, text input, leave it like that, and then specimen, there was a circular dog bone specimen, so circular, and the diameter 25 inch, 0.25 inch, length 1 inch, and final length it's just a value that we have put it in. So final length should be greater than 1 inch, so we put like 3.9 something. Final diameter should be less than that, 0.25, but yet we put just a value. So it's just the same thing, like just a point ahead. So it doesn't matter the final length or final diameter, just to throw some values in it. So nodes, if there are any specific nodes, we don't need that for now. Input numbers, leave it like that. So measurements, what measurements we have selected, extension, time, load, tensile strain, tensile extension, tensile stress. That's the thing we want to like measure. Setup, calculation, what calculation we want, selected calculation, area reduction, maximum load, minimum load, rounding, we don't need any rounding, test control, we want to start the test by start button, strain 1 we want to measure for this test because it's a cyclic strain rate test. So we choose strain instead of extension. So pre-test, we don't need any, so these are all blank. Test, do we just write a description like profile description, cycle strain rate at 4.667 e to the power minus 5 per second. So this is the strain rate we can edit if we want using this data. So maximum, minimum, modes, shape triangle, like this means that triangle, the load extension will go up and then come back down. So the minimum is minus 0.0178, so there will be strain and then it will come back. So it's saying that in millimeter. So this is and there's also option to see the graphs like loading. So triangle, we select that. If it's like a only going up, so there is no minimum load options. So we select triangle, so there will be maximum and then come back down to minimum. So save change, no, won't save anything for now. End of test, how we want to end the test, measurement events, tensile stress. So if the tensile stress reaches 500 megapascal, it will stop. And how will what will be the end of the action, stop, and console, live display, what do you want to see, extension, load, tensile stress. So you can see every 4 item is at the top, extension, load, tensile stress, and tensile strain. Soft keys, we don't really need any, but we can add some if we want. Frames, below crosshead, threshold if we have any. So if it goes 56 pound force, then the test will go off. Grips, we don't need any. Workspace, select parameters to display on the test workspace, we don't need any. Results, what results we want, maximum load and minimum load, these are the units. And then statistics, if we want. For now we don't need any. Formats, what formats we want to get the data, maximum loads and minimum, in terms of each cycle of strain. So we want to see the loads for maximum loads for straining up, and then minimum loads when we are compressing. So results 2, if we need any, no. So graphs, what we want to see in the graphs, this is the format. X data, tension, Y data, tensile stress, graph 2, extension in load x-axis, load in y-axis, advanced if we need anything specific. So raw data, what raw data we want to take out from the test, time, extension, and load. Format, which format we want to see. Colors, if we want to add. This looks good. Extra display, if we want to see extra. Layout, any layout we can choose from here. And basics, these are the basic. Custom, if we want to custom. Exports, if we want to export any specific file in a specific name, so we don't need any. So this is the example of how should be a cylindrical cyclic strain rate testing methods to write. In this method, there will be a fixed strain rate, and we will measure the load it takes to get that much strain in every cycle. So this is a good example, but again, when you writing your method for the first time, have someone by you who has written the method before, and gain some experience. Use the easiest one and then try your one. It should work good. Good luck. So when the method is all written, to run the test we have to go to the test button and then select methods. So if the method is already written, we can select. So as there is a dog bone specimen, stainless steel, so we can run cyclic loading of 100 megapascal. It's in elastic limit, so it should not harm the specimen. We'll select that. So it will ask for the sample name. So sample name should be like test 304 stainless steel, whatever I want to write, and then I have to press next. So it's kind of ready. It will show the results, the graphs, what we have selected for this test, and all the terms at the top we wanted to see during the test. And if we press the start button, it will start the test. But before starting the test, you can see there is already a tensile stress working on the test. Load like 296 Newton. So we have to do balance it before run the test. Balance. So you see now there is no load, no stress, no extension. So this is the load. It will show up like 0.02 newton. It's really low. It's due to the airflow through the room, through the experimental area. So it will go up and down. As long as it's like 0.01 newton, it's like okay. If you want to pause the test anytime, you can pause it. There's also some options if you want to go through load, gains, checks. So another important thing I want to show that here there's a frame look button. If we click it, it will show frame analog output. So if we want to connect this Instron testing machine with another system like say 3D DIC, digital image correlation system, so we may want to get data, analog signals out of this software to another system. So we can use that. There's 4 cables. This one that takes out this wire 4 analog signals from the frame, and we can take the data to here the system, 3D DIC system. For in this case, these are the signals it can take from the frame to further analyze. So we can select tracking, output mode, connector, extension. In each line should be selected for different things. Like for first one, I selected labeled as load. For line Y, it's 3 labeled as strain, and then line Y1 is extension again. So this is the window where we can select what kind of analog data we want to take out from the system when running the test. So we can filter, we can set 0, full scale, to get the data. So this is the pretty much basics to write a method. So now we'll run the test. The load is minus 18 newton, so we need to balance here. So now we don't have any extension, any load, preload, so we're ready to run the test. We will start the test. So the software is getting ready. Now the test is going on. Now you can see the load is, the stress is building. It should go up to 100 megapascal, that the way we have set it up. And after reaching 100 megapascal, it will come down. Here you can see it is coming down, and also the load upon reaching a limit is coming down. Instead of getting this graph, we can plot time versus extension, how much extension or strains we are getting. So as the way the cycle is designed, it should go down to minus 100 megapascal, and then it should jump again up to 100 megapascal. So now the stress is going down. You see here the tensile stress is minus 100, so it's going up again. It will hit again to the tensile stress of 100 megapascal, and there's a bump at the 0 because there's a change of stress, and it's going up, and will hit again the 100 megapascal, and it should go down again. So this is the way the cycle will keep going. Depends on how much cycle I have. We have planned to do like 10 cycle, or like 20 cycle, 100 cycle. So for now we don't need that. I'll stop the test right now. So this is for just an example. I'll stop here.